A brown rat can squeeze through a hole the width of a quarter. It can fall 5 stories onto concrete and walk away without a broken bone. It can tread water for 3 straight days, chew through cinder block, and reproduce so fast that a single mating pair can generate as many as 15,000 descendants in 1 year. That is enough warm bodies to fill a small sports stadium. Rats outlived the woolly mammoths. They outlived the saber-toothed cats, and the giant ground sloths, and the short-faced bears. They survived ice ages that buried entire continents under glacial sheets, 2 kilometers thick, taller than 6 Eiffel Towers stacked on top of each other. They survived supervolcanic eruptions that dimmed sunlight across the planet for years. They have survived every mass poisoning campaign, every extermination program, and every apex predator that has tried to wipe them from the face of the earth across 65 million years of unbroken evolutionary success. 99% of every species that has ever lived on this planet is extinct. Rats are not. So why does a $2 snap trap with a smear of peanut butter still kill them every single day? The answer is uncomfortable, because it does not stop at rats. The instinct that kept them alive for 65 million years is the exact same instinct that walks them into the trap. The scent of calorie-dense food triggers a neurological response so ancient and so deeply wired into the rat brain that no amount of danger can override it. The rat does not weigh the risk. It does not analyze the strange wooden platform or wonder why food is sitting in an unusual place. The scent hits the olfactory bulb, the survival circuitry fires, and the body moves toward the food before any higher processing can intervene. That sequence kept every single ancestor of that rat alive long enough to reproduce, across millions of unbroken generations, without exception, until someone figured out how to use it against them. That is not a rat problem, that is a biology problem, and you carry the exact same one. Not with peanut butter, with a molecule. A molecule that has been quietly steering your behavior for 10 million years. Long before you were human. Long before you had language or fire or any concept of what a trap even is. The molecule is ethanol. And the story of how it went, from the single adaptation that may have saved your species on the floor of a dying African forest, to the substance that now kills 3 million people every year, according to the World Health Organization, a figure roughly equal to the entire population of Chicago, is the most unsettling evolutionary inheritance that most of us have never been told about. It starts with a single amino acid, buried deep in the genetic code of a primate that had never seen a glass, a bottle, or a bar. In 2014, paleogeneticist Matthew Kerrigan at the Foundation for Applied Molecular Evolution in Gainesville, Florida, published a study in the Proceedings of the National Academy of Sciences that quietly rewrote the entire timeline of humanity's relationship with alcohol. Kerrigan, working alongside biologist Stephen Benner, sequenced the ADH4 enzyme, a protein responsible for metabolizing alcohol, from 19 modern primate species. Then they did something nobody had ever attempted at this scale. They worked backward, reconstructing the ancestral versions of that enzyme across 70 million years of primate evolution, essentially building a molecular time machine out of genetic data. What they found in those reconstructed enzymes was remarkable. For tens of millions of years, the ADH4 protein in our tree-dwelling ancestors was practically useless against ethanol. It could process other alcohols found in leaves and plant matter, particularly a compound called geraniol that plants produce as a chemical defense. But ethanol, the specific alcohol that yeast creates when it ferments the sugars inside ripe fruit, barely registered. The enzyme could not break it down efficiently. An ancient primate living in the canopy that accidentally ate fermenting fruit would have gotten sick. Then, approximately 10 million years ago, a single amino acid substitution occurred in the common ancestor of humans, chimpanzees, and gorillas. One molecular edit in one protein. And that one edit made the ADH4 enzyme 40 times more efficient at metabolizing ethanol. Kerrigan's team confirmed this by actually resurrecting the ancient versions of the enzyme inside bacteria in a laboratory and testing them head-to-head against ethanol. The performance gap was enormous, 40 times the processing speed from one change in one gene. The timing was not a coincidence. 10 million years ago, the global climate was cooling. The dense tropical forests that had sheltered primates for millions of years were shrinking, thinning, retreating toward the equator. The common ancestor of the African great apes was being pushed out of the canopy and forced down to the ground. And on the forest floor, the rules of survival changed completely. In the treetops, fruit hangs ripe on branches. You reach out, you grab it, you eat it fresh. On the ground, fruit falls, it sits in the heat and humidity. Yeast colonizes the sugars. The fruit begins to ferment. The sugars convert to ethanol. And for any primate that could not handle that ethanol, that fallen fruit was essentially off limits. They got nauseated. They ate less. They lost access to an entire food source. Over thousands of generations, their lineages thinned and eventually vanished. The primates that carried the mutated ADH4 enzyme could eat fermenting fruit without getting sick. They could extract calories from food that their competitors could not touch. On a forest floor, where resources were scarce and competition was brutal, that advantage was the difference between a lineage that survived and one that disappeared. That mutation is still inside you right now. Every time your body processes a drink without immediately shutting down, you are running a piece of molecular machinery that was selected for on the floor of a shrinking African forest, 10 million years before anyone invented a glass. And here is the detail that makes this story hit differently. That same ancient advantage, that same molecular trick that kept your lineage alive, would eventually become the exact mechanism that traps you. But that is getting ahead of the story. By the way, this idea that ancient survival instincts become modern traps runs through almost every part of your biology. Your cravings, your fears, your social wiring, your relationship with food and risk and reward, all of it traces back to adaptations that solved ancient problems and now misfire in a world those adaptations were never designed for. I put together an ebook that covers the full system, every evolutionary mismatch still running your decisions without your permission. If that interests you, the link is in the description below. But back to the forest floor, because the mutation was only the first chapter. In the year 2000, a professor of integrative biology at the University of California, Berkeley, named Robert Dudley, proposed something that initially sounded ridiculous to his colleagues. He called it the drunken monkey hypothesis. The core idea was simple, but it carried implications that made a lot of people uncomfortable. Dudley argued that human beings are not attracted to alcohol because of culture, not because of advertising, not because of peer pressure or habit or weakness. The attraction exists because of a deep evolutionary wiring that connects the smell and taste of ethanol to survival itself. His reasoning went like this. For frugivorous primates, meaning primates whose diet centered on fruit, ethanol was not a poison, it was a signal. When yeast ferments the sugars in ripe fruit, it produces ethanol as a byproduct. That ethanol is volatile. It evaporates quickly and disperses through the air as an aromatic plume. In a dense tropical forest where ripe fruit is scattered across enormous distances and hidden by layers of canopy cover, the smell of ethanol drifting through the trees was essentially a chemical beacon. Follow that scent and you find food. But the advantage went further than just locating fruit. Ethanol contains nearly twice the caloric density of carbohydrates, 7 calories per gram of ethanol compared to 4 calories per gram of sugar. A primate eating fermenting fruit was getting significantly more energy per bite than one eating fruit that was fresh. In an environment where calories were scarce and a dozen other species were competing for the same food, that caloric edge mattered. Over evolutionary time, it mattered a lot. 22 years after Dudley first proposed the hypothesis, direct confirmation arrived from a small island in Panama. In 2022, a study published in Royal Society Open Science by Christina Campbell and colleagues documented wild black-handed spider monkeys on Barro, Colorado Island actively seeking out and consuming fruit from the jabo tree. The jabo fruit had alcohol concentrations between 1 and 2%, roughly equivalent to a very light beer. When the researchers collected urine samples from 6 of the monkeys, 5 contained secondary metabolites of ethanol. The monkeys were not encountering alcohol by accident. They were eating it routinely, digesting it, and their bodies were processing the ethanol as fuel. Dudley himself noted that the monkeys were probably not getting drunk. their stomachs filled up before they could consume enough ethanol to become intoxicated. But the physiological benefit was measurable and real. More calories per gram, more energy per feeding session, a competitive advantage in a forest full of animals fighting over the same resources. And there was a detail that most coverage of the study missed entirely. The ethanol in fermenting fruit does not just provide extra calories, it stimulates appetite. Modern researchers call this the aperitif effect. A primate that consumed fermenting fruit would eat more food overall, absorbing additional vitamins, minerals, and sugars alongside the ethanol. The monkey that followed the smell of alcohol to a pile of rotting jabo fruit on the forest floor did not just find one food source. It found a chemical that made it hungrier for everything else around it. I mean, think about that for a second. The reward pathway that lights up in your brain when you catch the scent of wine at a dinner table is the same pathway that once guided a primate through dense tropical vegetation toward a pile of fermenting fruit. The wiring has not changed. Only the input has. The same jabo fruit that those spider monkeys eat in Panama has been used for thousands of years by indigenous populations throughout Central and South America to produce chicha, a fermented alcoholic drink. The line between the monkey reaching for fruit on a jungle floor and you reaching for a glass on a kitchen counter is not a metaphor. It is a direct evolutionary inheritance. But the story of ethanol and survival does not end with foraging. The next stage in the relationship between humans and fermentation solved a problem that was far more immediately lethal than finding food. It solved the problem of keeping food from killing you. Before refrigeration existed, before salt curing was developed, before canning or pasteurization or anything resembling modern food science, there was fermentation. And fermentation was not a recipe for making drinks. It was the first reliable food preservation technology in human history. The chemistry is straightforward. When yeast and bacteria convert sugars into alcohol and organic acids, the resulting chemical environment becomes hostile to the pathogens that cause food to spoil and become dangerous. The lactic acid produced during fermentation drops the pH of food to levels where killers like Clostridium botulinum and Salmonella cannot survive. The ethanol produced during alcoholic fermentation adds its own antimicrobial barrier. Together, these byproducts create a chemical fortress around the food, extending its usable life by weeks or even months. For Paleolithic humans living in environments where food availability swung wildly with the seasons, where a surplus of berries or wild grain or honey could appear for a few weeks and then vanish entirely, this was transformative. A harvest that would normally rot within days could be converted into a stable, calorie-dense, nutrient-enhanced form that lasted through the lean months. Fermented food also required less energy to digest. The microorganisms had already begun breaking down the complex proteins and fibers before the food ever entered a human stomach. It was, in a very real sense, pre-digested. Anthropologist John Spieth at the University of Michigan noted in 2017 that fermentation and putrefaction offer foragers a significant energetic benefit by softening food and pre-digesting component proteins and fats before ingestion. For populations surviving brutal northern winters with limited fuel for cooking fires and diets heavy in raw animal protein, the ability to store fermented food in skin bags and clay pots was not a luxury. It was the margin between surviving to spring and starving in February. The ancient humans who discovered that leaving fruit or grain in a sealed vessel produced something that lasted longer, tasted different, and made their bodies feel warm were not inventing a recreational beverage. They were inventing a survival technology, and the alcohol was simply what happened along the way. This decision seemed small at the time, leaving food to sit and transform. But it was not small. It was the beginning of a chain that would reshape the entire trajectory of human civilization, because the people who mastered fermentation did not just survive longer, they eventually started brewing on purpose. And the earliest evidence of that intentional brewing was not found in a kitchen or a granary or a storehouse. It was found in a graveyard. In 2018, archaeologist Li Liu at Stanford University published a discovery in the Journal of Archaeological Science that pushed the timeline of deliberate beer production back thousands of years earlier than anyone in the field had expected. Working alongside Dani Nadel of the University of Haifa, Liu analyzed residue from 3 stone mortars recovered from inside Rakafet Cave, a Natufian burial site nestled in the Carmel Mountains near Haifa, in what is now northern Israel. The mortars were approximately 13,000 years old. Inside them, Liu's team identified starch granules and microscopic plant particles called phytoliths that showed unmistakable chemical signatures of malting, mashing, and fermentation. The wheat and barley starches had been transformed through the exact sequence of steps required to produce beer. Not wine, not mead, beer, brewed from cereal grains, by hunter-gatherers who had not yet begun farming a single crop. The beer itself would have looked nothing like what sits in a refrigerator today. It was thick, closer to a porridge or a watery gruel, with a sour tang from wild lactic acid bacteria. Cloudy, gritty, unfiltered, and likely consumed while still actively bubbling with fermentation gases. Jiajing Wang, a doctoral student on Liu's team, described it as a multi-ingredient concoction that modern palates would struggle to recognize as beer at all. The Natufians were a semi-sedentary foraging people who lived in the Levant during the transition between the Paleolithic and the Neolithic. They did not plant their grain, they gathered it wild from the hillsides. And yet they had developed a multi-step brewing process, germinating seeds, heating the mash, and allowing controlled fermentation, sophisticated enough to leave chemical traces detectable 13,000 years after the last batch was brewed. But the part that keeps researchers awake is not the age of the beer or the sophistication of the process, it is the location. Rakafet Cave was not a home. There were no signs of regular habitation, no cooking hearths, no sleeping areas, no everyday domestic debris. It was a cemetery. The Natufians buried their dead inside the cave, sometimes on beds of flowers arranged with obvious care. And next to those graves, they brewed. Liu was direct about what this meant. Making alcohol was not necessarily a result of agricultural surplus production, she stated. It was developed for ritual purposes and spiritual needs, at least to some extent, prior to agriculture. The Natufians were not brewing because they had leftover grain with nothing else to do. They were brewing because the dead required it. That distinction reshapes the entire origin story. It means that one of the oldest deliberate production processes in human history was not economic, it was sacred. Alcohol entered human civilization not through the kitchen but through the grave, not as entertainment but as ceremony. The first intentional brewers on Earth were not trying to have a good time. They were trying to honor the dead and process the grief of losing them. Think about that next time you see a toast raised at a funeral. The ritual is 13,000 years old. The impulse behind it may be far older. And if the Natufians were brewing beer before they were growing grain, that raises a question that has divided archaeologists for more than 70 years. A question that touches the foundation of everything we call civilization. In 1953, botanist Jonathan Sauer proposed an idea that most of his colleagues considered somewhere between provocative and absurd. He suggested that the original motivation for cultivating cereal grains was not bread, it was beer. The implications of that idea are staggering. Because if Sauer was right, then the Neolithic Revolution, the single largest turning point in human history, the moment when nomadic hunter-gatherers settled into permanent farming communities and began reshaping the surface of the planet, was driven not by hunger, but by thirst. For decades, the idea stayed on the margins of academic debate. It was interesting, but unprovable. Then the evidence from Rakafet Cave arrived, and suddenly the timeline fit. Deliberate fermentation of cereal grains 13,000 years ago. The earliest confirmed bread remains from a Natufian site in eastern Jordan, dating to a similar period. Beer and bread appearing together at the dawn of agriculture, but the beer brewed in a ritual context that suggests it held a purpose beyond simple nutrition. And the geography tells its own story. Genetic analysis conducted by researchers at the Norwegian University of Life Sciences in Oslo demonstrated that the earliest domestication of einkorn wheat, one of the founding crops of agriculture, occurred in the vicinity of the Karakatag Mountains in southeastern Turkey. That location sits within walking distance of the most extraordinary archaeological site on Earth, Göbekli Tepe. The site sits on a limestone ridge in southeastern Turkey, overlooking the flat expanse of the Harran Plain. It dates to approximately 9600 BCE, making it roughly 11,600 years old. To put that age in perspective, Göbekli Tepe predates Stonehenge by about 6,000 years. It predates the Egyptian pyramids by more than 7,000 years. And it was built by people who had not yet invented agriculture, pottery or permanent settlements of any kind. The ruins are dominated by massive T-shaped limestone pillars carved with animal reliefs: foxes, boars, snakes, vultures, each pillar weighing more than 10 tons, roughly the weight of a loaded city bus. The pillars are arranged in circular enclosures that archaeologists believe served a cultic or ceremonial purpose. There is no evidence that anyone lived at Göbekli Tepe permanently. People came from surrounding regions across considerable distances, gathered at the hilltop, performed rituals, and left. And when they gathered, they drank. Archaeological analysis of 6 barrel-shaped and trough-shaped limestone vessels recovered from the site revealed residues consistent with the fermentation of cereal grains. Some of these vessels could hold up to 160 liters of liquid, enough to fill a standard bathtub. Chemical testing identified probable traces of calcium oxalate, a compound commonly produced during the brewing of barley beer. The results, published in 2012 in the journal Antiquity by Oliver Dietrich of the German Archaeological Institute and his colleagues, were described as preliminary but strongly suggestive. Dietrich stated the conclusion plainly. Production and consumption of alcoholic beverages was an important factor in feasts, facilitating the cohesion of social groups and in organizing collective work. Pay attention to what that means. The construction of the oldest monumental architecture anywhere on Earth, a building project requiring the coordinated labor of hundreds of individuals from scattered communities who shared no common settlement and no formal economic system, may have been organized around the brewing and communal consumption of beer. The alcohol was not a reward handed out after the heavy lifting. It was the mechanism that made the heavy lifting possible in the first place. It was the reason people showed up. The chain runs in a direction that most history textbooks never describe. The temple required collective labor. Collective labor required feasting. Feasting required beer. Beer required grain. Grain required cultivation. The earliest agriculture on Earth may have emerged not because someone was hungry for bread, but because a Neolithic priest needed barley for the next ceremony. If that sounds like an extreme claim, consider the fact that the very location where the first wheat was domesticated sits practically next door to the oldest temple ever built. Oliver Dietrich did not think this was coincidence. And no, that connection is not something I am inventing. It is sitting in the peer-reviewed literature, and nobody talks about it. But the role of alcohol in building civilization did not stop at temple construction. It solved a far more mundane problem, a problem that was killing people by the thousands in every settlement, every village, every early city that depended on a local water source. For most of human history, drinking water was dangerous. Rivers carried parasites picked up from animal carcasses upstream. Wells were contaminated by waste from livestock pens built too close to the water table. Standing pools bred mosquito larvae and harbored bacteria responsible for dysentery, cholera, and typhoid fever. Ancient humans did not know what a pathogen was. They had no concept of germ theory, but they figured out, through countless generations of painful observation, that people who drank certain prepared beverages got sick less often than people who drank water straight from the source. Beer was one of those beverages. The brewing process requires heating water, which kills many of the microorganisms responsible for waterborne illness. The alcohol produced during fermentation has its own antiseptic properties, further inhibiting bacterial growth. And the low pH of fermented liquid creates an environment where many common pathogens simply cannot survive. The Sumerians of ancient Mesopotamia treated beer not just as a daily drink, but as medical equipment. Historical records preserved on clay tablets indicate they employed up to 19 different formulations of beer in wound treatment, using the antimicrobial properties of fermented grain to clean and dress injuries across the body. One Mesopotamian prescription describes mixing beer with botanical compounds, spreading the mixture directly onto damaged skin, and binding the wound with cloth. A 2024 study published in the Journal of Development Economics by researchers examining historical mortality data in England confirmed what ancient civilizations had understood through pure observation. When beer availability decreased due to malt taxation, mortality from waterborne diseases increased in a statistically measurable way. The beer that people were drinking in that period averaged roughly 0.75% alcohol by volume, weaker than most modern non-alcoholic beers, essentially functioning as purified water with a faint buzz. Food scientist Charles Bamforth described the brewing process as an inadvertent water purification technique. You boiled water, you added grain, You let it ferment and you got a liquid that would not give you cholera. For thousands of years, across dozens of civilizations spanning Mesopotamia to medieval England, the safest thing a human being could put in their body was not water from the nearest stream. It was beer. The medicinal uses of alcohol extended even further. In the tomb of Pharaoh Scorpion I, one of the earliest rulers of a unified Egypt, archaeologists discovered clay jars dating to approximately 3150 BCE, more than 5,000 years ago. When biomolecular archaeologist Patrick McGovern of the University of Pennsylvania Museum applied advanced chemical analysis to the residue crusted inside those jars, he found wine infused with a deliberate selection of botanicals known to have therapeutic properties. This was not recreational drinking, this was pharmaceutical manufacturing. The wine served as a solvent, extracting active chemical compounds from herbs that water alone could not dissolve, and preserving them in a stable, consumable form. McGovern, who has spent decades analyzing ancient residues from sites across the Mediterranean and Near East, described the role of wine in ancient medicine bluntly. It was simultaneously an antiseptic, an analgesic, and an antimicrobial. The Greeks used wine mixed with boiled water and vinegar to cleanse battlefield wounds. The Roman physician Claudius Galen documented standardized alcohol-based wound treatments as early as the 2nd century. Egyptian physicians prescribed medicated wines. Chinese practitioners extracted herbal remedies using alcohol as the base solvent. Sumerian healers combined beer with botanical preparations in formulas that were recorded on tablets, standardized across cities, and passed between generations of healers. If you are starting to notice a pattern here, good, because every angle of this story points in the same direction. Alcohol was not some accidental vice that early humans stumbled into. It solved real, concrete, measurable problems at every level of ancient life. Calories, preservation, hydration, medicine. But the most important problem it solved was not physical at all. It was social. If you are finding this useful and you want to understand how these ancient biological systems still shape the decisions you make every single day, hit subscribe. I cover the deep evolutionary forces behind human behavior every week. The algorithm stops showing you this channel if you do not, and what comes next in this story is the part that connects everything. In 2021, philosopher and cognitive scientist Edward Slingerland at the University of British Columbia published a book called Drunk: How We Sipped, Danced, and Stumbled Our Way to Civilization. The central argument was carefully built and deeply uncomfortable. Slingerland proposed that alcohol is not an evolutionary mistake. It is not a design flaw in the human brain. It is a social technology, one of the most effective ones ever deployed, and it solved a problem that no other tool in the human repertoire could touch. The problem was trust. Human beings are tribal primates. We evolved in small bands of closely related individuals where cooperation was enforced by kinship and by the simple reality that you saw the same faces every day. In a group of 30 or 40 people who are all related and who all depend on each other to hunt, gather, and defend territory, cheating is risky because everyone knows everyone. Reputation matters. Betrayal has consequences. But as human groups grew larger, as trade networks expanded and strangers from different valleys and different language groups needed to cooperate on projects like irrigation canals and temple complexes and defensive walls, the old mechanisms of trust fell apart. You cannot rely on kinship to enforce cooperation when you are building something alongside a person you have never met before and might never see again. You cannot track the reputation of every individual in a settlement of 5,000 people, a number roughly equivalent to the population of a small college campus. Alcohol, Slingerland argued, provided a shortcut through this impasse. Ethanol suppresses activity in the prefrontal cortex, the region of the brain responsible for analytical thinking, self-monitoring, and impulse control. When the prefrontal cortex is chemically dampened, people become more emotionally open, more willing to share personal information, less guarded about their real intentions, and less capable of maintaining a strategic social mask. This is not just a subjective feeling, it is measurable in laboratory settings. Studies in social psychology have demonstrated that moderate alcohol consumption increases interpersonal trust, willingness to cooperate in economic games, and emotional disclosure between strangers. Slingerland pointed to what he called the costly signal theory of intoxication. When you lower your cognitive defenses in the presence of another person, you are making yourself vulnerable. You cannot easily fake emotions or conceal your true motivations while intoxicated. And vulnerability, in evolutionary terms, is one of the most powerful trust signals that exist. A person who is willing to become impaired in your presence is demonstrating, through action rather than words, that they do not consider you a threat. This is why virtually every human culture that has encountered alcohol has woven it into social ritual, diplomatic negotiations, business agreements, religious ceremonies, marriage celebrations, peace treaties between warring groups. Across every continent and every century of recorded history, the pattern repeats with almost mechanical consistency. When humans need to build trust quickly with people they do not know well, they sit down and drink together. Slingerland's conclusion was stark. We would not have civilization without intoxication. The large-scale cooperation required to build cities, organize armies, administer empires, and maintain trade routes spanning thousands of kilometers depended on a chemical tool that could override the tribal instincts of a primate brain that was never designed for anonymous collaboration. Alcohol did not just lubricate social interaction. It made the kind of social interaction that civilization requires neurologically possible. While all of this was happening at the social level, alcohol was also opening a door in the brain that had nothing to do with trust. It had to do with ideas. There is a well-documented and somewhat awkward relationship between alcohol consumption and creative problem-solving. Studies in cognitive psychology have repeatedly shown that moderate intoxication, enough to impair focused analytical thinking, but not enough to impair basic motor function, actually increases performance on tasks that require creative insight and novel pattern recognition. The mechanism traces back to the same prefrontal cortex suppression that enables trust. When the prefrontal cortex is fully active, it excels at linear, sequential, rule-bound thinking. It keeps you focused. It filters out associations that seem irrelevant. It suppresses unconventional connections between ideas and enforces a cognitive discipline that is extremely useful for executing known procedures. But it is terrible at innovation. Innovation requires seeing connections between domains that appear unrelated. And the prefrontal cortex, when fully engaged, actively prevents you from seeing those connections. When ethanol dampens that filter, ideas that would normally be dismissed as irrelevant suddenly feel connected. Solutions that the sober mind would never consider become visible. For ancient communities facing survival challenges that had no precedent, from engineering water management systems to developing new hunting technologies to navigating the complex politics of multi-clan alliances, the ability to periodically think outside the rigid grooves of focused attention may have been genuinely adaptive. A group that occasionally entered a state of collective reduced inhibition around a communal fire was, in a very real sense, running a distributed brainstorming session. Not every idea generated during a feast would be useful, but the ones that were could change the trajectory of the entire community. Slingerland argued this creativity benefit was not a side effect. It was one of the functional advantages that kept alcohol use stable across human evolution, despite its obvious physical costs. The species that drank together did not just cooperate better. They generated more novel solutions to collective problems than species that did not. But creativity and trust only address the intellectual and social dimensions of ancient life. They do not touch the emotional one. And the emotional reality of Paleolithic existence was something that modern humans, buffered by hospitals and insurance policies and climate-controlled apartments, can barely imagine. Infant mortality in Paleolithic populations exceeded 50%. More than half of all children born did not survive to adulthood. Starvation was seasonal and expected. Predation was constant. Injuries that you would treat today, with a bandage and some ibuprofen, a broken femur, a deep laceration from a flint tool, an infected molar, were frequently fatal. You watched your children die. You watched your hunting companions die. You carried the knowledge every single day that the same fate was waiting for you, and there was very little you could do to prevent it. Modern humans have built elaborate systems to buffer the psychological weight of mortality. Ancient humans had almost none of those systems. What they did have was ritual. And ritual, across virtually every documented culture in the archaeological and anthropological record, involved intoxication. The psychopharmacological effects of ethanol, reduced anxiety, temporary euphoria, emotional openness, social bonding, are precisely the effects that would counteract the chronic psychological stress of living in a world where death was an everyday visitor. A community gathering around a fire to share a vessel of fermented honey or wheat-grain beer after a devastating loss was not engaging in escapism. It was engaging in collective emotional processing. It was using a chemical tool to temporarily lift the cognitive weight of awareness, in a world where awareness was often agonizing. The evidence from Rakafet Cave supports this directly. Beer production was physically located next to graves. The living brewed in the presence of the dead. The act of communal drinking while surrounded by the buried remains of people you loved was a ritual technology for managing grief, for marking the transition between life and death, for acknowledging the weight of mortality without being destroyed by it. Every civilization that followed would develop its own version of this practice. The Irish wake, the Jewish Shiva with its communal meals, the ancient Greek symposium, where wine flowed while philosophers debated the nature of death. The mechanism was always the same across millennia and across oceans. Gather the living together, share the drink, process the loss, and then continue. Alcohol did not make ancient life less dangerous, but it may have made the constant awareness of that danger survivable. If your ancestors had been psychologically crushed by grief every time they lost someone, and they lost people constantly, they would have stopped functioning. They would have stopped hunting, stopped gathering, stopped reproducing. The species would have collapsed under the weight of its own consciousness. The drink was not a weakness. It was a pressure valve that kept the machine running. And fermentation was delivering benefits that went beyond the psychological and even beyond the social. It was quietly transforming the nutritional quality of everything ancient humans ate. When microorganisms ferment food, they do far more than produce alcohol. They restructure the nutritional profile of whatever they consume. Fermentation breaks down complex carbohydrates into simpler sugars that the human gut can absorb more readily. It degrades anti-nutritional compounds like phytic acid, a molecule that binds to essential minerals like iron and zinc, and prevents the intestinal lining from absorbing them. It synthesizes B vitamins, particularly folate and riboflavin, that were not present in the raw food at all. And it populates the food with colonies of beneficial bacteria that strengthen immune function and digestive efficiency. For ancient populations eating diets that were often monotonous, seasonally restricted, and nutritionally incomplete, fermented foods and beverages served as a critical supplement. A grain porridge that had been left to ferment for several days was measurably more nutritious than the same porridge consumed fresh. The fermentation had improved the food by outsourcing digestive work to microorganisms, organisms that could break down fibers and proteins that the human stomach could not handle on its own. This is why fermented foods appear in virtually every food tradition that has ever existed on Earth: Korean kimchi, Japanese miso and natto, Ethiopian injera, the spongy sourdough flatbread that serves as both plate and utensil, European sauerkraut, West African ogi, fermented from corn or sorghum, Indian dahi. The specific ingredients vary by geography and climate, but the underlying technology is identical everywhere it appears. Let microorganisms process the food before you eat it, and you extract more value from every bite. The ancient populations that figured this out were not making a lifestyle decision. They were gaining a survival advantage that was measurable in stronger bones, better immune response, fewer nutritional deficiencies, and more efficient calorie extraction from the same raw materials. In a world where every calorie mattered and where a deficiency in a single micronutrient could weaken you enough to die from an infection that a well-nourished body would have fought off, fermentation was not a cooking technique. It was a survival technology as important as fire. And here is where the trail leads somewhere that most history textbooks skip over entirely, because the economic implications of fermented beverages are so vast that they reshape how you understand the first great civilizations. When the pharaohs of ancient Egypt organized the construction of the pyramids at Giza, they confronted a logistical challenge with no precedent in human experience: Tens of thousands of laborers needed to be fed, hydrated, and compensated. Day after day, for decades. Not enslaved workers, as popular culture often assumes. Salaried laborers. People who showed up, did back-breaking work hauling limestone blocks that weighed as much as 2.5 tons each, roughly the weight of 2 adult hippos, and expected to be paid. The payment was beer. Archaeological excavation of workers, villages near the Giza Plateau confirmed that pyramid builders received daily rations of bread and beer. Some estimates place the daily beer allotment at 4 to 5 liters per worker, roughly equivalent to filling a large water bottle twice. This was not a party. The beer was weak, nutritionally dense, and calorically significant. It functioned simultaneously as hydration in the desert heat, as food to sustain grueling physical labor, and as compensation for services rendered. It was paycheck, water bottle, and lunch combined into a single, thick, sour, grain-heavy liquid. The Egyptians were not alone in building their economy on beer. Across Mesopotamia, beer rations were a standard unit of worker compensation embedded into the administrative infrastructure of the state. The oldest known written recipe in human history is a Sumerian hymn dedicated to Ninkasi, the goddess of beer, dating to approximately 1800 BCE, roughly 3,800 years ago. The hymn is simultaneously a prayer, a cultural artifact, and a detailed set of brewing instructions. It describes the entire production chain from preparing the bapir, a twice-baked barley bread used as a fermentation starter, to filtering the finished beer through woven reed mats into ceramic collecting jars. Beer was so deeply integrated into the Mesopotamian economy that it functioned as a unit of exchange, a form of taxation, and a measure of social standing. Workers were paid in it. Priests received formal allocations of it. The state controlled its production and distribution the same way a modern treasury controls currency. The scale of ancient beer production was industrial by any definition. Archaeologists working at Hierakonpolis, an ancient city in Upper Egypt, uncovered a brewery complex dating to approximately 3400 BCE. That is nearly 5,500 years ago. The facility was capable of producing over 1,000 liters of beer per production cycle, enough to fill roughly 5 standard bathtubs. At Abydos, a site associated with early Egyptian royal burials, an even older brewery dating to approximately 3000 BCE, contained rows of large ceramic vats arranged in what can only be described as parallel production lines. Systematic, standardized, designed not for a household but for an entire labor economy. And this economic integration of alcohol into the machinery of civilization created a feedback loop that fed itself in every direction. The demand for beer drove the demand for grain. The demand for grain drove agricultural expansion into new territory. Agricultural expansion required labor. Labor was compensated with beer. The beer required grain. The grain required more labor. The cycle was self-sustaining, and it operated continuously for thousands of years across the most productive agricultural region on the planet. When historians describe the earliest economies as grain-based, they often fail to mention that a significant portion of that grain was never eaten as bread. It was brewed into the liquid currency that paid the workers, who grew the grain that was brewed into the currency that paid the workers. The economic engine of early civilization ran, in substantial part, on ethanol. If you had to choose between a cup of water drawn from the Nile and a cup of weak beer brewed from barley in ancient Memphis, which would you actually drink? The water could kill you. The beer kept you alive, kept you fed, and counted as your wages for the day. For the workers who built the pyramids, the choice was not even close. The temples collected grain as tax. The grain was brewed into beer. The beer was distributed to laborers. The laborers built the temples and farmed the fields. The fields produced grain. The grain was collected as tax. The circle closed perfectly, and inside that circle an entire civilization operated for 3,000 years. So here is where the story arrives at the question embedded in the title of this video. Why do rats still die in a trap if they outlived the mammoths? And why do humans still reach for a bottle when every hospital ward in the world can show you exactly what it costs? The answer is the same in both cases, and it is the same answer for every evolutionary trap that exists in nature. Every entry in this story describes a genuine benefit. Ethanol provided calories on a forest floor where food was scarce. It signaled ripe fruit across distances that the eye could not cover. It preserved food through winters that would have otherwise meant starvation. It purified water that would have otherwise carried fatal pathogens. It delivered medicine. It generated trust between strangers. It enabled the cooperation required to build temples and cities and pyramids. It unlocked creative thinking. It provided psychological relief in a world saturated with grief. It improved the nutritional value of food. It powered the earliest economies. For 10 million years, these benefits were delivered at concentrations that the human body had co-evolved to handle. Fermenting fruit on the forest floor rarely exceeded 2 or 3% ethanol. Early beers were weak, thick, and consumed communally in ritual settings with built-in social limits on how much any individual could drink. The amount of alcohol available to any single human was constrained by the amount of grain or fruit a community could produce, the slow pace of natural fermentation, and the social norms surrounding when and how and with whom drinking occurred. The system was balanced, the benefits were real, the costs were manageable, the trade-off held. Then humans invented distillation. The process, refined during the medieval period, but with roots stretching back to ancient alchemists working in Persia and China, allowed ethanol to be extracted and concentrated from the 2 or 3% found naturally in fermented beverages to 40, 50, or even 90% by volume. In a single technological step, the ancient survival signal that had once meant food and community and medicine was amplified to a concentration that the human body had never encountered in 10 million years of evolutionary history. The leap from 2% ethanol in fermenting fruit to 40% ethanol in a bottle of distilled spirits is not a gradual escalation. It is a 20-fold increase in potency, roughly the difference between standing in gentle rain and being hit by a fire hose. And it arrives in a form that completely bypasses the natural safeguards that once limited consumption. A spider monkey eating jabo fruit in Panama fills its stomach long before it can ingest enough ethanol to become dangerously intoxicated. The fiber, the pulp, the water content of the fruit, all of it creates a physical barrier that caps intake. A human being drinking distilled spirits has no such barrier. The ethanol arrives concentrated, stripped of everything that once accompanied it, and it hits the ancient reward pathways with an intensity that no forest floor and no Neolithic brewery could ever have produced. Robert Dudley, the Berkeley biologist who first proposed the drunken monkey hypothesis, described modern alcohol misuse in exactly these terms. It is a disease of nutritional excess. The same formulation applies to obesity, to diabetes, to every condition where an ancient survival instinct collides with a modern environment that delivers the trigger substance in quantities that the instinct was never calibrated to handle. Every instinct that kept your ancestors alive is now operating in a world for which it was never designed: the attraction to the scent of ethanol, the caloric reward that follows consumption, the warm flush of social bonding, the easing of anxiety, the loosening of rigid thought patterns. Every single one of those responses was shaped by 10 million years of evolution in an environment where ethanol arrived, diluted, bundled with fiber and nutrients and water and beneficial bacteria, always in modest concentrations, always in communal settings with social limits on intake. The bottle in your refrigerator triggers every one of those ancient responses, but the concentration inside it is something your genome has encountered for less than 1,000 years. Your body does not know the difference between fermenting fruit on an African forest floor and 80-proof spirits in a glass tumbler. It responds the same way it always has, with the instinct that kept your ancestors alive long enough to become your ancestors. This is the paradox that sits at the center of every evolutionary trap. The things that saved us are the things that now destroy us. The caloric instinct that prevented starvation across ice ages now drives obesity in a world of unlimited processed food. The social bonding mechanism that built the first civilizations now fuels addiction in a world of unlimited distilled ethanol. The sugar craving that once guided primates toward ripe fruit now pulls children toward vending machines, loaded with concentrations of fructose that no piece of fruit could ever contain. The survival tool becomes the survival threat, not because the instinct changed, because the environment changed around it. The wiring is ancient, the inputs are modern, and the gap between the two is where the trap springs shut. The rat in the snap trap is not stupid. Its ancestors survived everything the planet threw at them for 65 million years, precisely because that food-seeking instinct was so fast, so reliable, so deeply embedded that nothing could override it. The instinct worked perfectly in every environment the rat had ever encountered. Forest floors, grasslands, caves, sewers, barns. It worked for millions of generations without failure. It just never encountered a spring-loaded bar attached to peanut butter. The rat cannot distinguish between a food source that will sustain its life and a food source that will end it, because for 65 million years, it never needed to make that distinction. Food was food, calories were calories, follow the smell, eat, survive, reproduce. That was the entire program, and it ran flawlessly until the environment introduced something the program had no code to handle. You are running the same program. The version in your brain is more complex. It operates through different pathways and responds to different molecular triggers. But the underlying architecture is identical. A signal hits the ancient circuitry. The circuitry says this is good, this means survival, move toward it. And the body responds before the conscious mind has any say in the matter. The mammoth went extinct because its world changed faster than its biology could adapt. The grasslands dried up. The temperature shifted. The megafauna diet that had sustained it for hundreds of thousands of years disappeared within a few thousand. The mammoth's survival instincts, perfectly tuned for an ice age environment, became useless in a warming world. The instincts did not fail. The world moved out from under them. The rat survived because its instincts were generalized enough to work across almost any environment. Almost. The snap trap is the one edge case that its 65 million years of evolution never prepared it for. A concentrated, isolated, perfectly positioned trigger, sitting on a mechanism designed specifically to exploit the response. Distilled alcohol is yours. 10 million years of evolution told your ancestors that the smell of ethanol means food, means calories, means survival. That signal was accurate for every environment your lineage ever inhabited. Forest floors, savannas, Neolithic villages, Bronze Age cities, medieval towns. The signal was always right, until someone concentrated the molecule 20 times over and put it in a bottle on a shelf. The mechanism has not changed. The dosage has. Every fermented fruit on every forest floor your ancestors ever walked across contained a truth that is still operating inside you right now. The smell is survival. The taste is reward. The warmth is safety. Those associations were written into your neurology across 10 million years of selection pressure, so intense that the primates who did not carry them simply ceased to exist. The rats who outlived the mammoths are still dying in traps. The primates who outlived the ice ages are still reaching for bottles. Not because either species is foolish. Because both are running ancient software and modern hardware, and the ancient software has no patch for a problem that did not exist when it was written. The next time you pour a drink, you are activating a circuit that was first tested on a piece of fermenting fruit lying on the floor of a thinning forest in Africa, 10 million years before you were born. The circuit works exactly the way it was designed to work. It has not malfunctioned, it has not degraded. It is performing the precise function that kept your ancestors alive long enough to produce the unbroken chain of descendants that eventually became you. It just does not know that the world has changed. And it responds the same way it always has. If you want to see more of the evolutionary history that quietly controls your decisions, click the video on the screen now.